Today, we're going to look at exponential functions, but rewriting them with exponent rules. And we're also going to pull in regressions. We've done regressions before, just going to do them in our exponential functions. So some exponential functions can be rewritten in a more simplified form using our rules of exponents. So the two rules that we're going to be using today is the power rule, power to a power. When you have an exponent raised to an exponent, you multiply those together. Let's just talk about a quick example. Let's say I have x squared and I cube it. That would be an x squared, x squared, x squared. There would be three sets of two there. You would add them all up and you would have x to the sixth. Okay, write that out, expand it if you need to. X squared, x squared, x squared. There would be six total x's. The other exponent rule that we're going to use is if you are, and we kind of just illustrated it, if you are multiplying same bases, you add their exponents. So as an example, let's say x to the fourth times x cubed. If I expanded it out, those four x's and then three more would be a total of 7, or 4 plus 3, x to the seventh. There is that exponent rule. So let's look at number 1. The number of views of a viral video can be modeled by the function L of t equals 700 times 3 raised to the 2t. Write an equivalent function in the form of L of t equals a times b raised to the t. So we just want an a, we just want a b, and only raised to t here. So what's the difference? Well, right now we have 2t. We want to get rid of that 2 that's up there in our exponent, okay? So I have L of t equals 700 times 3 raised to the 2t. Now we're going to use our exponent rules a little bit backwards. So go up and let's look at that first exponent rule. It said if we had exponents that were multiplying, m and m, if they are multiplying, it was originally m on the inside, n on the outside. Okay, so right now we have 2 and t multiplying on the outside. So let's shift it using that exponent rule. Let's shift that 2 inside, so it's 3 squared raised to the t. Okay, now I know what 3 squared is. That's 700 times 3 squared is 9 raised to the t. Did I reach that goal of that equivalent form? I got an A, 700. I got a B, is 9, and only raised to the t. I got it. So that's all we're doing here, just using that exponent rule to rewrite, and we are finished. Let's try again. Number 2, we got bacteria in a lab experiment can be modeled by S of t equals 45 times 3 raised to the t plus 1. Let's rewrite in an equivalent form. S of t equals a times b only raised to t. Only difference is we had t plus 1. So let's look at the second exponent rule. It said if they were adding, it's equivalent to if I split them up into separate. So let's see, we had the 45. We're keeping the same base. We have a 3 raised to the t times 3 raised to the first. Using that second exponent rule just directly above, I know what 3 to the first is. I have 45 times 3 to the first is a 3, and then we'll have 3 raised to our t. Let's do 45 times 3 is 135. So we have something like S of t equals 135 times 3 raised to the t. Final answer. Number 3, the amount of revenue for a business can be modeled by W of t equals 7,200 times 3 raised to the 2t plus 2. Write it in the equivalent form, a times b only raised to t. We've got a lot going on here. We got 2t plus 2, and we just want our exponent to only be t. So we're going to apply both rules. Let's see. Let's first split it up into 2. Let's get rid of the addition. Let's say 7,200. We have 3 raised to 2t and 3 squared. Well, I know what 3 squared is. That's 9. So 7,200. We'll multiply that with the 9. And then let's take care of this other piece. We have 3 raised to the 2t. I could rewrite that as 3 squared t. 3 squared is 9. 7,200 times 9. Then our base is 3 squared, going to become 9 raised to the t. Let's clean this all up. W of t equals 7,200. I'm grabbing my calculator. 7,200 times 9, 64,800. When I multiplied those two together, and then we still have 9 raised to the t is my final answer. Almost ran out of room there. Number 4, value of the car depreciates over time, can be modeled by m of t equals 18,000 times 0.9 raised to the 2t. Write it in equivalent form. So let's split it up. It was 2 times t. We want it to just be t. We can take care of that 2 by shifting it inside. 18,000, 0.9 squared would only be raised to the t, but clean that up. Let's see what 0.9 squared is. Of course, 0.81 raised to the t, and I think I'm done. Let me just label this m of t equals done. All right, next part, recall that a calculator can produce a regression to model the relationship between two variables. This is our line of best fit, but we've also seen it as linear, as quadratic, and now we're looking at it as exponential. So we're going to input our data into our calculator. The calculator is going to find that regression or that model, that function that fits the data best. An exponential regression is a method to find an exponential function that fits our data set. That's what I said. I got your calculator steps listed there, and let's use number 5 as our example. So grabbing my calculator, let's start off with, we're going to go from the home screen to a list in spreadsheets. You can do that from new document, or you can use that center app there to get a list in spreadsheets. I don't need to save. Number 4, list in spreadsheets. And we're going to enter all of our data in column A and column B, and we'll have to label each column at the top. Let's see what we're working with. The accompanying table shows the value of the car over time that was purchased for $16,400, where X is years and Y is the value of the car in dollars. Write an exponential regression equation. It tells you what to do. Rounding all coefficients to the nearest hundredth. We'll have to pay attention to that. And then using the equation to determine the value of the car after 8 years. We'll plug in 8 for X because X is years. Cool? So we got to come up with our equation, round it correctly, and then we're going to plug in 8 into our equation. So let's fill in our data on our calculator. Column 1, we've got 0, 1, let's do 1, 2, 3, and 4. Column B, 16,400, 13, 630, 12, 399, 10,351, 9,449. Okay. Let's go up to next to our letters and label. You can get fancy or you can keep it simple. I'm going to call it X and Y. Now, if you do multiple problems on your calculator, either start with a new document or start naming them something different, because when we go to the next steps, it will list everything that you've ever used in this document. And so if you keep labeling them X and Y, you'll forget which one is which. All right, after that, let's slide over and see. To find our regression, we're going to go to Menu, Statistics, Stat Calculations, and we want to look for exponential regression. We have done quadratic, we've done linear regression, we've done quadratic, and now we're in exponential land. So A is exponential regression. Here's where you choose your list. I called them X and Y. This is what I was saying. If you keep calling them X and Y, they'll list all the X's and Y's, and you won't know which one is which. So one way to get avoid that is just start with a new document every time. Those are the only 2 things we need to change on this this table. So use the tab to get you down to the OK, and it's going to list all that information for you. Our exponential regression is our title. It is A times B raised to the X, where A is going to be 16,080.6949. Now, in the cell, I can only see 0.6. Do you see at the bottom of our screen, there's equal, like D3 equals 16,080.6949, da, 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 da. So if you need more decimal places. If your calculator is not showing you all the decimal places, let's try, I'll show you that in a minute. I'll show you where you can change your settings, okay? Our B is going to be 87 or 0.87127, and it's got our R and some other values here, but we just need the A and the B. In our directions, it said we were rounding all of our coefficients to the nearest hundredth in our equation. Nearest hundredth. So let's see. Y equals A times B to the X. Don't forget your Y equals the A 16080.100.694. The 4 tells us let it rest. So 69 is going to be my A value there. Our B, let me arrow down, 0.871 says let it rest. And then raised to the X. There's our equation, keeping the X. Part 2, we're going to put in 8 for X. So let's grab a new page, calculator. 1680.69 times 0.87 raised to the, we're plugging in 8. Enter. Let me slide this over. Our final value after 8 years is 5,277.8701. I don't remember how we're rounding to the nearest cent. 2 decimal places, so I have a 0. So it says let it rest. So 5,277.87 is final answer for part 2 after I evaluated with the equation. Now I said if your calculator is not showing all your decimal places, go to your home screen and check your settings on document settings. If you're not seeing all your decimal places, document settings, you want to make sure this first one says float. I think sometimes it defaults to float 3. And what that would mean is it tells the calculator float my digit view, only show me 3 digits. It doesn't matter where the decimal is. I might need more decimal places than 3, or I might need more digits than 3. If it's 827, it's only going to show 827, not any other decimal places. So you want to make sure this is on float, okay? And then just tab and hit OK, all right? That's how you can check that. So that is rewriting our exponential functions. I've seen benchmark questions already with this, rewriting them, equivalent forms. We're only using those 2 exponent rules. Practice with those and let me know if you have questions. And then we are using the regression function again on our calculator. Again, we've done this with linear. We've done it with quadratic, and now we're just revisiting now that we're in exponential functions. And that's just where you have like a scatter plot and you're trying to fit your data. So it could have a quadratic shape, or in this case, we're looking at it when it has exponentials. And really the only way to do it is with our calculator. So obviously we would expect it to be in a calculator section question on a benchmark or your end of course test. So guys, practice that. Those are the only 2 exponent rules we're using. They just take a little bit of practice. If I went too fast, let me know. Be happy to help you, and I'll see you later in class. Have a great day.